So, dear students, this is Dr. Venkatachalapathi, Institute of Aeronautical Engineering. So, I would like to discuss an important topic in welding process, that is effect on HAZ in welding. The term HAZ means heat affected zone in a welding process. Especially, the term welding can be defined as it is the process of joining two similar metals or dissimilar metals by adding filler metal without adding filler metal, by application of pressure and temperature without application of pressure and temperature. These six terminology is very, very important while defining this term welding. So welding is a traditional process. During Second World War itself it has been existed. After that there is a advanced, still the research is going on, the advanced welding techniques has been introduced like laser welding and uh, beam welding, etc. Okay, so in that the main important concept hedge heat affected zone. What is the effect of heat effect zone in welding? We'll discuss in detail in this video. Let us see the what is meant by a heat affected zone on a welding. I hope the student you can able to understand clearly when you wanted to joining a two pieces, either similar or dissimilar metals. So first you should able to clean the that work pieces with the files, different type of flat or rough files and all. We should clean the all the surfaces with like a smooth surfaces. Then while performing the welding process, what you will do, you can see there is a color indication, blue color and yellow color. The blue color where you can see the weld metal. The blue color while performing the welding. So through torch with the help of the filler rod. Okay. So there the blue shape we can call it as a some sector shape, that is called weld metal. So nearby that weld metal some rectangular shape, that is also called as a heat affected zone. So while heating, while joining two metals with that electrode rod, some heat will be generated. So due to that heat, some affected zone will be expand or compress, and some unaffected. So before welding, this is called the unaffected base metal. After doing welding process, there is a heat affected zone. So that's what is a very interesting one. The term heat affected zone is that area of the metal that has not been melted and has undergone changes in properties as a result of being exposed to relatively high temperatures during welding process. I hope here the student should able to understand clearly heat affected zone. Majority of the student they simply in every manufacturing technology lab what you call technical assistant only performing welding. Here I will give you some instruction. The student, you yourself perform a welding with your own so that you can able to identify where you have to touch that metal, and after taking the precautionary goggles and hand gloves, etc., you can able to understand where why the heat effect zone occur in that two metal pieces, where it will occur. While you perform, then only you can able to identify. So otherwise, if somebody is performing this process, the student can able to distinguish between the unaffected base metal and heat affected zone metal. Okay, that is what the term heat affected zone on a welding process. It is the area of the metal that has not been melted. Is it clear? That has not been melted and has undergone changes in properties as a result of being exposed to relatively high temperature during welding. Whenever the metals will be vary the one metal to temperatures, automatically sudden changes of the temperature, some effect will be occur in that metal. So that is what about heat affected zone. In this heat affected zone, you should be able to understand clearly three major important points. The first point is the weld interface. The weld interface in the sense it is the difference between unaffected zone to the weld metal, that is called weld interface, which is also referred to as some mushy zone. So this is called some mushy zone. So where It is a narrow zone consisting of a partially melted base material. So sometime only melted, the remaining unmelted. So obviously when you test it for the microstructure, it leads to be some good strength, and some strength of the metal also will be very very poor. So that is why which has not got an opportunity for mixing. So the proper mixing of that electrode or filler rod and this metal will not mix it properly, so that the zones separate the fusion zone and heat affected zone. There are the two zones. One is fusion, when it melted, it will become fusion takes place, and there will be heat affected zone. So this is what about the weld interface occur at the mushy zone. And second important point is it refers to the non-melted area of the metal, non-melted area of the metal that has an experienced changes in the material properties. Especially we are using sometimes similar metal or dissimilar metals, that the property of the material will be changes as a result of exposure its temperatures. For example, that is what ferrous and non-ferrous, sometimes ferrous also cast iron and steel, both are different temperature will be changes. Suddenly each material will have a different metal will solidify, the other metal will have, due to that differences only, this heat affected zone will occur. Some strength and some weak parts also will be occur due to this heat affected zone. And third interesting point is the alternations in material properties are usually as a result of welding or high heating cutting procedures will be followed. So this is what about the main heat affected zone and welding process. This is what very important for the competitive examinations also. Even while attempting the interviews also, they will ask clearly what is the main HAZ which will act on that welding process. You can able to explain with the help of this neat sketch also. Okay. Now let us see the clear structure of the heat affected zone. It is a color indicates, you can able to understand clearly. Whenever the temperature in the vertical axis, the maximum temperature, in the horizontal, the changes of its structures, that is in a blue, yellow, red, and rose, and light rose, and gray blue color, and dark, that porous in nature things. Why it happens, whenever the heat affectation, when you start performing the welding process, in this case like that, and if you see the structurally the starting how the unaffected zone base metal, so it is a some black like a porous in nature. So whenever the temperature, when start welding, what will happen, the tempered zone, so that the fusion takes place. Then next stage, partially the transformer zone, it will be tempered zone will be changes to partial transfer zone whenever the temperature can be rises. Okay. Then recrystallized zone, this is what the term recrystallization means, changing of old nuclei into new nuclei. This is what you can see clearly, how here there is no small molecules, this will be enlarged. So that's called recrystallization zone. The term recrystallization can be defined as it is the process of changing old nuclei into new nuclei. That you can clearly understand the red symbol, how the enlarging of that molecules. And further, the grain growth zone, this is what about once again formation of the molecules, it will be expand or enlarge it, it will growth, that grain growth zone, that is also called as a grain growth zone. Next, still it is further increasing to maximum temperature. Solid liquid boundary takes place wherever the solid weld metal is. This is what the blue color. So it will be some outer excess metal also can be removed by some what you call some chipping hammer to be used removing that overheated things. Okay, so I hope this can clearly understand that color indication and how the structural changes in that heat effect zone, starting with the welding. So when you, for example, the two metals are there, when you touch it automatically, first initially unaffected base, once you can touch it, there will be some fusion takes place, the temperature can be increases, and when it touch the metal and the filler rod, both some mixing will be take, partial transformation will occur, then recrystallization, grain growth, and solid liquid boundary. Finally, solid weld metal, that the cover can be eliminated by chipping hammers to be used to remove the excess heated untransformed zone. Okay, so this is what about the diagrammatic representation of heat affected zone in a welding process. I hope the student can understand clearly about the HAZ on welding. Now let us see the another interesting point I would like to add in this case. It can often be recognized by series of brightly colored bands. As you know that there will be in this two workpieces, either it may be a similar or dissimilar. This is a workpiece 1 and workpiece 2. There is a series of changes in color bands. Okay, there is a rose, yellow, and orange color, and again this is a weld bead, and again the color indicates. Okay, so it is a like two plates you can keep here. When you touch it, when you move it, so this front view, if you see the top view, you can clearly understand the color bands. Okay, so that are visible near that welds only. Whenever by performing, immediately it will be disappear. While performing welding only, the color bands will be shown, and these colors are caused by surface oxidation. So, and at the approximately indicator of the temperature reached by the metal. So whenever it will reach red hot at metal, and so due to the temperature reaches, the color indication also will be changes. This is what about the how effective heat affected zone will start from this weld bead, weld metal onwards to this total color indication. So this is the base metal, and this is the weld bead. In this structure we will call it as a weld bead, and this is called the heat affected zone, and this one and this one. Okay, that basically depending upon the whenever the first case base metal, when you heat it, filler and electrode will be touches, there will be incomplete transformation structure takes place, and when it is annealed zone, fine grain structure will be takes place, excessive heating zone, that is coarse grain structure will be takes place, and finally melting zone is the transition zone. At that only the two metals will be joined together, and by solidification time it will be get ready for the joining. Permanent joint will be occur. So that's called weld metal is melted part will be shown in this middle. Okay, so this is what about the heat affected zone can be explained in the colored bands, brightly colored bands, so that the temperature variation will be analyzed clearly. Okay, now let us see the how the temperatures with the degrees of Fahrenheit or degrees of centigrade with the color indication. So in this case, you can easily understand the light yellow. So where the temperature is 290 degrees centigrade, if it is converted into Fahrenheit, 550 degree Fahrenheit. So straw yellow color, where it will increase the temperature 340 degrees centigrade, and where if you convert into a Fahrenheit, 640 degree Fahrenheit. When it is in a yellow brand, 370 degree centigrade, if it is in a Fahrenheit, 700 degree Fahrenheit. And when it will brown color, again it will be increased another 390 degrees centigrade, and when it is a purple brown, the 392 will transfer to 420 degrees centigrade, where in Fahrenheit 735 to 790. And dark purple means we can achieve the temperature 450 degrees centigrade, and where in the case of Fahrenheit 840. Okay, and blue, dark blue. So finally blue, dark blue, where you can see here, this is a final joining of that, that is the dark blue, that the temperature 600 degrees centigrade, when it is converted into Fahrenheit, 1110 degree Fahrenheit is dark blue. Okay, so as a result of using the different temperature while manufacturing process are joining two metals or similar metals, a variety of tints is presented in this heat affected zone. This is what this Okay, variety of tints can be presented. This can be mainly, this tint range from light yellow to the dark blue color, light yellow to dark blue, while increasing the temperature ranges 290 degrees centigrade to 600 degrees centigrade, where the Fahrenheit 550 to degree Fahrenheit to 1110 degree Fahrenheit, it will varies. So this is what about the clear indication of the heat affected zone in any type of metals while performing the fabrication or joining of two similar or dissimilar metals. Now let us see the what are the main factors, affect in a HAZ on welding process. These colors also called the heat tint. We can also name this term called heat tint. So this sometimes they may ask in competitive examinations. Okay, what the colors used in HAZ will name it as a heat tint. So it is depends on the four major factor. One is the steel chromium content, oxygen level, and the rougher. Okay, rougher. So here let us see the in a steel chromium content what happens. This metal increases the material resistance to oxidation, therefore the colors will be a less intense, isn't it? So similarly, when oxygen level during welding, usage of protective gas and electrode coating can reduce the coloration because of the costly shield metal from the oxidation. That is called the oxygen level. The third important thing is rougher. The surface, the faster it oxidizes, causing dark colors. So these are the three major important steel chromium content, oxygen level, and finally the rougher. Okay. So this is what about the heat intake place in a HAZ. And what are the various causes, especially anything you can write the cause effective diagram of HAZ, heat affected zone. What are the various causes which will affect of the heat affected zone, and in this causes, what are the effects? So main causes, you can see the first heat effect zones can be varying the size and strength. Size and strength. So because of the size and strength, what are the various factors will affect this heat affected zone? Okay, and especially the extent and magnitude of heat affected zone is inversely proportional to the thermal diffusivity and cooling rates of the material. This is the first point. And where the thermal diffusivity is high, the material cooling rate is high. Obviously, the HAZ will be very, very small. So thermal diffusivity, cooling rate will be high. That HAZ is very small. Heat affected zone will be very small. Suppose the diffusivity and material cooling rate is low, heat affected zone will be enlarged, will be higher. So that is what will be larger or higher. So this is what about causes which will affect. So these are the factors will affect of the this heat affected zone. Steel, chromium content, oxygen level, and the rougher will take place effectively. And look at this is a 3D diagram of heat affected zone. So especially if you take a microstructural appearance while performing the welding process, any two pieces of metal are similar or dissimilar metals while performing a welding process, immediately if you take into that structure into the microstructure, these are the real three-dimensional figure. This is what FZ, heat affected zone. Okay, fusion zone. This is called fusion zone. This is heat affected zone. Heat affected zone. This is also called HAZ. Okay, so the HAZ is the crucial area in a welding. HAZ is a crucial area in a welding because once the steel has been selected, the HAZ and its properties have also to be accepted, whereas weld metal can be changed if necessary. So whenever the welding steels, HAZ is very important as an area where cracking can occur as well as region whose properties can reduce by welding process. This is what about the the clear understanding of heat affected zone in a real life applications. When you perform two metals are similar or dissimilar metals, obviously the HAZ will occur in this real time application. So if you take that diagram with a microscopic structure, so this is what how differentiate between the fusion zone to a heat affected zone. Okay, so this is what about heat affected zone in a real life application. So I hope this is what about major important thing in the heat affected zone on a welding process. So by conclusion, let us see this is the a general line diagram of how the heat affected zone can be explained diagrammatically with the unaffected base metal and heat affected base metal, and this is the weld metal. The three terminology: weld metal, unaffected metal, in between only heat affected zone. So next, these are the color codes structure of heat affected zone, where it starts from the unaffected zone base material to solid liquid boundary, which will covers tempered zone, partially transferred zone, recrystallization zone, grain growth zone, etc. So initially the structures, there's some porous in nature, then it will start small molecules will occur, then in the recrystallization it will enlarge old nucleus into a new nucleus takes place, in a recrystallization takes place, then the growth, grain growth will be takes place, then boundary will be occur, and finally at achieve the maximum temperature, the joining can be performed better. So this is what about the various structural changes in the heat affected zone. And even this bright color bands also will be explained with the base metal, some incomplete transformation, it is a some orange color, some yellow, what you call light orange is annealed. So annealing means it is a heating, holding and cooling. So the main purpose of annealing is to relieve the internal stresses, improve the mechanical and magnetic and electrical properties. That is why their fine grain structure may be formed in this case. Then the fine will become a coarse grain structure, and finally the melting line, then weld metal of this thing will be take place. Okay, so in between weld bead to the base metal, we will call it as a heat affected zone. Okay, the place where the base metal to the weld bead will look it as a heat affected zone. But weld bead, this is all the fusion zone. We will call it as fusion zone or FZ. Okay, this is FZ. So next, according to this temperature, the color indication to the temperature range with the degree centigrade to degree Fahrenheit. It starts with light yellow to the dark blue, starting the temperature 290 degrees centigrade to 600 degrees centigrade, and Fahrenheit 550 to 1110 degree Fahrenheit, wherever the increasing order of the temperature takes place. So with this also called as tint, heat tint is in three major things. One is a steel chromium content or oxygen level content, and finally the rougher takes place whenever it faster it oxidizes, causing a darker colors will be occur. So these were the main causes for a heat affected zone, especially varying the size and strength. Obviously, thermal diffusivity, cooling rates of the materials also inversely proportional to the HAZ. That means if the thermal diffusivity is high, heat affected zone will be small. If the thermal diffusivity will be low, HAZ will become larger and higher. So with this, this is a three-dimensional structural changes in the real application of how it will appears in real life application, fusion zone and a heat affected zone. Mainly in a welding steels, HAZ is an important as an area where cracking can occur. So if it enlarges, the crack may be occur. So because of that will be some defect may be there. So in order to that, the properties also can be reduced by this welding process. Okay, so that is why this heat affected zone in welding is a very important and interesting one. Wherever in the competitive examination or some interviews also, they may ask this concept of heat affected zone in a welding process. Okay, so thank you students, thank you for this heat affected zone. The factors will affect on the welding in a heat affected zone. I hope the student can understand clearly. The next class we will discuss on another topic. Okay. Thank you. Thank you. Good luck.
Like, share and subscribe. Hit the bell icon for more updates.